Good day everyone. Today I'm going to present about my final year project. The title of my final year project is Analysis of the Characteristics of Microplastics in Synthetic Sewage. The agenda of my presentation including the introduction of microplastics, problem statement, aim and objective, methodology, result and discussion, and also conclusion. So, what are microplastics? Microplastics generally refer to plastic particles that are less than 5 mm in size. Microplastics can originate from a variety of sources including microbeads from personal care and cosmetic products, fibers from synthetic clothing, pre-production pellets and powders, and fragments degraded from larger plastic products. These smaller plastic particles can be ingested by aquatic organisms. The microplastics can be classified into primary and secondary microplastics. The microplastics can be distinguished in primary microplastics that are intentionally synthesized at defined small sizes for commercial applications. Primary microplastics are tiny particles designed for commercial use, such as personal care and cosmetic products, for example, facial cleanser and facial scrubs, toothpaste and shower gel, as well as microfiber sheet from clothing and other textures. Secondary microplastics are particles that result from breakdown of larger plastic items, such as water bottles, plastics bag, and fishing net. This breakdown is caused by exposure to environmental factors, mainly the sun's radiation and ocean waves. In my study, I will be focusing on the primary microplastics present in the personal care and cosmetic products, particularly refers to facial scrubs. Microplastics is a general term, so in order to be more precise, it is microbeads that are present in the personal care and cosmetic products. Microbeads became a big environmental issue just a few years earlier, when the environmental impact of this form of commodity are documented by Mother Jones and the New York Times. The toxicological problem with these non-biodegradable microbeads is that their material will not be decomposed by dissolution and will flow down a drain, getting deposited in the water where it will be more accumulated by the method of biomagnification and bioaccumulation. Microbeads, which are not permanent, non-degradable, and they are found in the water, often add to the demise of marine ecosystems and potentially being a human health detriment by ingesting contaminated fish. Secondly, the main issue due to the existence of microbeads in the atmosphere is that they are so tiny that they slip into the filter of waste treatment plants into the water systems and are then released into the ocean where they serve as contaminants that are able to migrate long distances through the water. As a matter of truth, they can be ingested by several animals, often at the base of the trophic chains. Lastly, there has not yet been any federal action or legislation explicitly aimed at minimizing the possibility of potential impacts from microbeads on the aquatic ecosystem. Because of the rapid development of the global plastics industry and the amount of plastic being produced, ASEAN has agreed that microplastics will be prohibited in personal care goods by 2020. At the same period, Asian countries such as Japan and Taiwan have also begun to rotate their usage of microplastics and are optimistic about it. However, there have never been any real proof and legislation of the flow of microplastics through the marine environment in Malaysia and also Southeast Asia. The aim of research is to study the characteristics of these primary microplastics presented in personal care and cosmetic products, specifically from different brands of facial scrubs. The following objectives are established to achieve the aim of this research: to investigate the presence of microbeads in personal care and cosmetic products, to extract and characterize the microbeads in personal care and cosmetic products, to compare microbeads extracted from different brands of facial scrubs. The methodology has divided into three parts, which the first step is to select the suitable facial scrubs, second step is to prepare the sample, and the last step is to extract the microbeads from the sample. The facial scrubs from different brands will be selected based on the ingredient listed and the availability of the market. The facial scrub chosen have found to be contain acyclic copolymer as one of the ingredients, which are commonly considered as the microplastics ingredient. A total of 5 different brands of facial scrubs are purchased, which include Vaseline Man Anti-Dullness Facial Scrub, L'Oreal Brightening Facial Scrub, Biore Deep Clean Facial Scrub, Garnier Anti-Acne Facial Scrub, and Nano White Facial Scrub. The second step is sample preparation. Each facial scrubs are labeled with numbers 1 to 5 accordingly. In particular, a total of 5 grams of each facial scrub is whipped and dissolved in 100 ml distilled water in a glass beaker. The mixture is then swirled with a glass rod until it was dissolved. In order to ensure that the mixture is completely dissolved, the glass beaker is placed on the magnetic stirrer at 45 degrees Celsius for 5 minutes. Then, the mixture is filtered using a grid 15 filters Fironi filter paper with a pore size of 2 to 3 micrometer and thickness of 0.14 millimeter by vacuum filtration to be sure that all of the microbeads has been captured. To further dissolve the solution and purify the particles, 20 ml of distilled water is added after the filtration procedure. After the particles are purified, the residue containing microbeads is oven dried for 24 hours at 37 degrees Celsius. The mass of the microbeads from each sample is weighed using an analytical balance and stored in glass vial for further analysis as soon as they are taken out from the oven. These are the photos taken of each sample after taken out from the oven. The samples abstracted are then sent to microscopy and analytical lab for further analysis. The extracted microbeads will be characterized by using different equipment, including optical microscope to identify the shape and color, particle size analyzer to quantify the microbeads, Fourier transform infrared spectroscopy to identify the microbeads composition. Unfortunately, due to the lockdown announcement, I was unable to get the results from the laboratories. Therefore, I have been reviewing the journals and articles that have the similar experiments as mine. According to Song 2015, combination of different microplastics identification methodology techniques, namely microscopic, spectroscopic, naked eye, and instrumental will help to recognize smaller microplastics. Besides, the extracted microplastics particles from any media is also influenced by filter size used in extraction step. As this study used 2 to 3 micrometer filtrous Fironi filter paper in extraction process, which was smaller than filter sizes used by Chong and Fook 2017, thus smaller filter size in extraction step has enabled smaller microplastics to be extracted and identified. According to Rana Zeshan 2020, the color of the microbeads is white, green, yellow, brown, red, blue, or black in color, otherwise without conspicuous color, which also known as colorless. From the results obtained, the dominating color from the extracted microbeads shall be known. There is also the possibility of extracted microbeads containing more than one color. Microbeads that contain more than one color can be separated manually by placing them under the microscope. Next, the shape of the microbeads can be classified as irregular, spherical, and granular. In fact, instead of spherical, the shapes of most microbeads would be irregular, primarily granular. Chong and Fook 2017 have also suggested that the majority of personal care and cosmetic products have granular and irregular shaped microbeads. On the other hand, polyethylene, low-density polyethylene, and polypropylene are the most common type of plastic polymer used in microplastics, and it will be the predicted polymer composition of the isolated microbeads. Moreover, similar plastic composition of low-density polyethylene in microplastics have been detected in facial scrubs by Chong and Fook 2016 and 17, Nepal 2015, Anderson 2016, and also Chang 2015. In personal care and cosmetic products, such as facial cleanser and facial scrubs. Microplastics with a diameter of up to 500 micrometer can be used and serve as replacement for natural exfoliating materials and scrubbing agents. According to Rana Zishan 2020, the expected range of size of microbeads extracted from facial cleanser and facial scrubs will be 12.3 micrometer to 273.4 micrometer, which is a large size range. More precise estimations are technically limited by the complexity involved in differentiating between irregularly shaped microbeads and secondary microplastics and the common usage of 335 micrometer mesh net. The microbeads extracted from the facial scrubs are found to have different colors with granular and irregular shapes range from 12.3 micrometer to 273.4 micrometer, depending on the brands of facial scrubs examined. The FTIR spectroscopy analysis revealed that the facial scrubs products included low-density polyethylene and polypropylene, the two most prevalent plastic polymers identified in microplastics. Moreover, further research may focus on the relative contribution of microbeads and ordinary fragmented plastic waste in ingestion events. Plastic microbeads in the environment have led to an increasing concern because they are directly available for ingestion by organisms upon their release. Unlike ordinary plastic waste, we know that microbeads have only one domestic source, which is from the personal care and cosmetic products. Recalling existing personal care and cosmetic products with plastic microbeads in their formulas may also be necessary to further reduce potential emissions of microbeads to the aquatic environments. Thank you for listening.